Howdy, it's been a while, but I'm glad to be back. This video is about one of the most important principles in software architecture, the Dependency Inversion Principle, or DIP. DIP comes from the legendary solid principles by Robert C. Martin, the Uncle Bob, and it is the foundation of the most widely used architectural patterns, such as clean architecture, ports and adapters, also known as hexagonal architecture, and also layered architecture. But what does it really mean? Why is it so important? Let's check it out. Before we go to the code, I'd like to talk very quickly about some theory. This is the clean code blog from Robert C. Martin, the Uncle Bob, and you can find all the solid principles here. For example, we have the single responsibility principle, the open-closed principle, and so on. But what about the dependency inversion principle? What is the definition? Robert is saying here, depend in the direction of abstraction. High-level modules should not depend upon low-level details. So your business rules classes should not know the implementation of low-level details, such as database, such as memory, such as caching, what else? You name it. Whatever you think about low-level, which is closer to the server, to the hardware, you should not implement inside your domain layer, your domain class. You are dealing with business rules, and suddenly, all of a sudden, you send an email, or you dispatch directly an Amazon SQS job. Inside the same method, you're dealing with the business rules. Is that what we should do? I don't think so. Dependency inversion principle is saying we should rely on abstractions. So how does it work in practice? For example, I have the user service class here, which basically tries to retrieve data from the MySQL database. Of course, it's not the real implementation. I only retrieve a simple string here with the SQL data. But this is only for example, okay? So what is happening inside my constructor method? I am instantiating my SQL database, and this is kind of a warning because what I'm doing here, it's making the user service tightly coupled with my SQL database. And user servers, if you are using the service layer repository pattern inside a layered architecture, usually will be business rule class. So should I implement according to the dependency inversion principle? Should I do that? This could be better if I play here. If I click on run code, I'm gonna see the string. Okay, but how this could be better? I could use dependency injection. So let me try to rewrite these. I'm gonna put like this: private MySQL, and I'm gonna put this variable name here. Nice. And instead of doing this, I'm going to remove this coupling from the constructor method. Okay. And now if I click on run, it's gonna fail because user service is not aware about the database class anymore. Now I should tell which class the user service should use. So let's see. I'm gonna put this variable right here, and now the database is gonna be my SQL database, but I'm gonna pass through the constructor method. Now I'm using dependency injection. What else? The service database. Okay. Oh yeah, I should remove this guy here. Now we're good. So what is happening here? I'm passing the dependencies through the constructor, and now I can change that if necessary. If I wanna change my SQL to other dependency, to PostgreSQL, to PostgreSQL database, for example, PostgreSQL database, I could do that, right? I only have to remove this guy here, but in order to this to happen, I would have to change my class here. So I would have to get inside the class and change manually. This could be even better. How so? If I go here to the right, I can use interfaces, and that's pretty much how dependency inversion works, because now I have two databases, my SQL database and PostgreSQL database, and the user service no longer is relying on implementation directly. It is relying on a database interface instead, and this interface implements the query method, which is a contract. Everybody that implements this interface, which are the MySQL database and the PostgreSQL database, they will have to implement the query method. Which one of them will implement according to the way it works? The only thing I should assure here is that the contract is the same, which is the method signature, the parameters, the input, and the output, the return. So that's how it works. So now user service doesn't know about how you implement your database layer. All you should do is get user and do whatever you want with that method and call the database query method instead. And the database, I don't know. Inside this context, I don't know who is the database, how it is implemented. This is not the role of user service to know. It's not the responsibility of user service. So yeah, that's how dependency inversion works. But Lucas, this is a very like simple example. Could you demonstrate in a real life scenario how that works? Sure. For example, I just installed Slim Framework here locally, and Slim Framework, it's a PHP micro framework. It is a very light framework, and the idea of Slim Framework is that you have more control over your implementations. That's ideal for those who like a more decoupled architecture. But dependency inversion, it is agnostic to programming language and agnostic to framework as well. So you could do what I'm explaining here in whatever language you like or whatever framework you like. What I like about Slim Framework is that the structure it's already modular. So for example, let me open the roots file here. Let me see, app roots. And basically the skeleton comes with an example of user listing So let's get this action. Actions are very similar to controllers on Laravel or Symfony, but they only have a single method, but they are compatible with the PSR7, which is about the HTTP interface. So we have a HTTP response here. And what this method does, basically tries to retrieve users from where. That's where dependency inversion shines, because if I click here on find all, where's the implementation? What is this? This is an interface, the user repository interface. And here I have two implementations, simple implementations, the find all and the find users of ID. But where's the implementation? How do I find? The implementation inside the Scalanta comes as an in-memory user repository, which goes inside infrastructure persistent user in-memory user repository. What is beautiful about dependency inversion is that if you need in the future to change your implementation, for example, let's suppose the users table have more than 100 million records, and all the simple queries are no longer able to retrieve with their proper speed. What should you do? You should change to another technology, such as Elasticsearch, for example. So I could go here and implement the Elasticsearch user repository. Nice, right? And this method is going to implement the same contract. And you can change this class for this other one without affecting your action or whatever you are using. A use case if you are using clean architecture, a service layer if you are using service layer in a layered architecture, port if you are using ports and adapters. In this case, we are doing this using the action that comes with this link, which is pretty much the controller. I'm doing directly from the controller, but the dependency inversion is here. But Lucas, should I apply dependency inversion everywhere? No, only it's when necessary. In this use case, for example, the persistence layer, it's a very common use case when a company reaches a certain level of growth, like those startups that are getting too big and becoming an enterprise company, they start to receive a lot of stress, a lot of access, a lot of concurrence. So the usual approach doesn't work. And this is a simple example, but usually at this point, the software is so big that if you chose in the beginning to do the coupled way, in order to change all the implementation would take weeks, months, maybe a year or more to change the implementation, because there are a lot of dependencies coupled to that class. And you don't have test coverage to test all of that. You don't have enough QA engineers to cover all those scenarios, all the modules that rely on that persistence. How can you do that? You would spend a lot of work, a lot of time, a lot of money, because you never thought about this kind of growth before. And this is so simple to do. This is a simple approach. Dependency inversion, it's so simple, but so efficient as well. So yeah, that's the real example that I'm trying to explain for you guys. I hope you could understand. You could even go even further and write, for example, more, like, for example, the queue version, if you'd like to save users using a queue service, for example. It's possible. So yeah, this is a very simple approach. When the time comes, we can explore better the repository pattern and cover more scenarios. This is very simple. That's not 100% how I like to implement the repository pattern, but as I said, this is only a skeleton that comes with this link, but works fine. It's correct in terms of isolation, and yeah, I hope I could explain well this concept for you guys with real life examples. So guys, that was my perspective about the subject, about how dependency inversion principle works in practice. It's how I use it daily. So if you found this useful, don't forget to like, subscribe, and I hope I see you next time. Bye bye.